Hey everybody, welcome to an asynchronous Friday. Because of conferences, we kind of missed a day, and so I'm just going to do our usual lesson, even though you guys can't help me answer it. I'll just go through the student activity sheet, kind of pretending that you're helping me to answer these questions. We'll get through it. The reason I want to make sure we get through this today is that you have a summative on this material coming up next week. So we're just going to talk you through it and just follow along, type along with me. So if you have not already opened this document, open the assignment, the 3.9B. It's the second day of this assignment. It's called, Is There Something Special About Wildebeest in the Serengeti? And so open that right now, and then we'll go ahead and get started. So we usually start with just a refresher of what we did the last time, which was a couple of times ago, because the last time we did the Snapshot Serengeti project. So it was the time before that. So the question says, what is the relationship between fires, grass, and wildebeest in the Serengeti? Justify your response, give evidence, and explain why, with data presented in day one of this lesson and previous lessons. So let's look at the data actually before we even try to type anything. So just reminding you, this was our student activity sheet 2 times ago. So we looked at these two graphs. This is a graph of the wildebeest population when it's at its peak, 1,500,000 animals. This is a graph when the wildebeest population is quite low at just 500,000 animals. If you look at the fires, it's about the fire and their fire intensity. We still have grass fires, normal grass fires, but the intensity of the fires is much greater when the wildebeest population is low. And the intensity of the fires is much less when there's a huge wildebeest population. Okay, so that's some data. Now, another piece of data. Remember, we looked at this graph and we saw the area that's getting burned by grass fires goes down as the wildebeest population increases. So this number, 1,500 thousands, that means 1,500,000 animals. So when the wildebeest population is at its highest, the percent of land that's getting burned is at its lowest. Okay, so let's try to answer that first question, the relationship between fires, grass, and wildebeest. So wildebeest, I hate typing that word, it's a hard word for me to type. Wildebeest eat grass. Fires become less, fire intensity goes down. Intensity goes down when the wildebeest population is high. There we go. Okay, so it says justify your response with data. So we're going to need to refer to the data. So in the graph of wildebeest population versus fire intensity, the more wildebeest, the less intense the fires. So they burn not as hot. They're not as damaging when there's a lot of wildebeest around. Why is that? Because the wildebeest are eating the grass, so there's very little fuel for the fire. In the graph, the second graph, the third graph really, the graph that was below, in the graph of wildebeest versus area burned, we'll just say that, area burned, less area burned when the population was high, because there was less fuel for these fires. So the fires did not burn as hot, they did not burn as much area. So then that takes us to the next question, which was kind of an interesting question, because we're just talking about the wildebeest, and we're saying that maybe the wildebeest are kind of important. And here we're going to take, not only are they important to grass, they keep the grass short, they're important to fires, how often those fires burn. But now number 2, why might a decrease in fire intensity and area burned cause an increase in tree density of the Serengeti? Justify your response with data presented from day 1 of this lesson. So remember that. Let's see if we can just type it out here. Fire kills plants. Frequent hot fires kill tree saplings. When the I'm sorry, I hate that word. When the wildebeest population is high, the intensity of the fires is lower, allowing more tree saplings. That's what a tree baby is. More tree saplings to reach adulthood. So they're growing up. And that's enough. It says justify your response with data, but we saw the data. So that was this graph right here. Oh, and there was another one. Where's that other data? Somewhere else. There we go. This is some more data where we looked at the trees and how many trees there are, and the density is increasing. Okay, that's enough for sort of the background. That's what we had done already. So continuing research, it says hypothesize. We're trying to figure out how wildebeest are important. We know they're important for grasses, for fires, their impact on the buffalo, and trees. So we've got some things that they're important. It says, how might the size of the wildebeest population directly or indirectly affect the size of giraffe population? KJ, we've never talked about giraffes. Well, let's hypothesize. We're just guessing here. So let's come up with some ideas. So first of all, we know that the wildebeest affect grass and trees. How could that relate to giraffes? So more wildebeest equals more wildebeest equals more trees because there's fewer fires. And what do giraffes eat? Trees, right? They eat the leaves from trees. So this is a hypothesis, equals more giraffes, right? They've got more food. Maybe other animals eat those trees too. So maybe it's not just giraffes. Maybe there's lots of other animals. Let's think also about predators. Who's eating giraffes? Well, very few predators can eat giraffes. Giraffes are super big and really hard to take down. In fact, almost never does an adult giraffe get killed. The only animal that really kills their offspring a little bit would be the lions, but it's a really hard thing for even the lions to kill because it's a big animal. Even their babies are big. So how are the wildebeest impacting, this is a guess, wildebeest impacting the predators? So if there's more wildebeest, what do you think is easier to kill from a lion's perspective? A wildebeest or a giraffe that's probably 3, 4, 5 times its size? I don't know numbers. I just made those numbers up, but way bigger. How about that? A giraffe that's way bigger. I think the predators are going to go for the wildebeest if they can. So if we've got a huge wildebeest population, then the predators can focus on the wildebeest and they can start ignoring the harder to eat and trap and hunt giraffes. So I bet the giraffe population is going to go up when the wildebeest population goes up. So this is my hypothesis, more wildebeest equals more predators eating wildebeest and not eating as many giraffe calves. And I guess I should say, well, I won't type it specifically, but that leads to then a bigger giraffe population. And I will tell you that giraffes are a threatened species. So that means that their population has been coming down due to kind of human things. And so anything that's going to help the giraffe population That's great for our ecosystem. All right, so let's double check. We've got some hypotheses. What does this article say about the wildebeest and giraffe populations? So I've got the article pulled up right here. I even highlighted, so this is what the article looks like. I even highlighted the section I wanted us to kind of focus on. There was a scientific study, and the study was published this week in the Journal of Ecology and Evolution from a team of international scientists, the USA, Tanzania, blah, 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 blah. It says the seasonal presence of thousands, hundreds of thousands, even more than 1 million, migratory wildebeests diluted local lion predation. So that diluted means lessened local lion predation and increased giraffe calf survival with significant effects on giraffe population dynamics. Ooh. Okay, so they're saying that the lions are not going to be attacking the giraffes, have not been attacking the giraffes as much, and we're actually seeing the giraffe population increasing, benefiting from the wildebeest population being large. So, supports. So, what does this article say? It supports the hypothesis that large wildebeest populations lead to increases in giraffe populations. Sorry, I had to move my picture. Giraffe populations because lions are hunting the wildebeest instead of the giraffes. If they have a choice, the lions would rather eat easy prey, wildebeest, than go after these big tall prey, giraffes. So that's good for the giraffes. There's lots and lots of wildebeest, and we're helping the giraffes at the same time. Okay, so now we've got a new word that we're going to learn. It's called a keystone species. A keystone species is a plant or animal that plays an important and unique role in how an ecosystem functions. Think about the wildebeest for a second. Are they really important? Think about the things we're talking about. Their impact on fire, on grasses, on trees, on giraffes, on buffalo. What other animals might they be impacting? Without the keystone species, I'm right here in my reading, without the keystone species, the ecosystem would be very different. What if suddenly 1,500,000 wildebeest vanished? What would that do to the Serengeti? How would that impact that ecosystem? One way scientists identify keystone species is to look at how changes to their abundance, how big their populations are, affect other organisms. Often there are many indirect effects of changes to the ecosystems. So here's a claim. We're going to take a look at a different keystone species and see if we can see why this species is identified as a keystone species. So here's the claim. Wolves are a keystone species in Yellowstone National Park. Again, that means that they are super important in the balance of that ecosystem because they have an impact on so many other plants and animals. So let's see if we've got evidence for that. So that's what we're going to do right now. We're going to watch the video and then we're going to type in some evidence. So this is the video. I have it pulled up. It takes about 4 minutes. It's really cute. The narrator is super enthusiastic. Let's see. I'm going to go, mine goes away for a second. My image goes away. Let me just tell you that with this video, they're talking about adding wolves back into Yellowstone National Park, which was done in 1995. Wolves were killed by humans, by human ranchers up to that point. So wolves had been missing from Yellowstone National Park for about 70 years. So imagine if the wildebeest had been gone from the Serengeti for 70 years. What would that ecosystem look like? And so now the wolves have been brought back, and imagine how they're impacting the Yellowstone National Park. So that's what this is about. I hope I can hit play. There we go. Okay.
Parents are quick to protect.
Done ad. Give me
just like raid, ant, and roach.
The pay is awesome.
How come it didn't start? There we go.
most exciting scientific findings of the past half century has been the discovery of widespread trophic cascades. A trophic cascade is an ecological process which starts at the top of the food chain and tumbles all the way down to the bottom. And the classic example is what happened in the Yellowstone National Park in the United States when wolves were reintroduced in 1995. Now, we all know that wolves kill various species of animals, but perhaps we're slightly less aware that they give life to many others. Before the wolves turned up, they'd been absent for 70 years. That the numbers of deer, because there was nothing to hunt them, had built up in the Yellowstone Park, and despite efforts by humans to control them.
I'm going to pause it for just a second. Sorry, but that narrator isn't from the United States, and he refers to these guys as deer. These are actually elk. So when he refers to deer, he's talking about elk. He's just using a different word than what we use when we see these animals.
They'd managed to reduce much of the vegetation there to almost nothing. They'd just grazed it away. But as soon as the wolves arrived, even though they were few in number, they started to have the most remarkable effects. First, of course, they killed some of the deer, but that wasn't the major thing. Much more significantly, they radically changed the behavior of the deer. The deer started avoiding certain parts of the park, the places where they could be trapped most easily, particularly the valleys and the gorges. And immediately, those places started to regenerate. In some areas, the height of the trees quintupled in just 6 years. Bare valley sides quickly became forests of aspen and willow and cottonwood. And as soon as that happened, the birds started moving in. The number of songbirds and migratory birds started to increase greatly. The number of beavers started to increase because beavers like to eat the trees. And beavers, like wolves, are ecosystem engineers. They create niches for other species. And the dams they built in the rivers provided habitats for otters and muskrats and ducks and fish and reptiles and amphibians. The wolves killed coyotes, and as a result of that, the number of rabbits and mice began to rise, which meant more hawks, more weasels, more foxes, more badgers. Ravens and bald eagles came down to feed on the carrion that the wolves had left. Bears fed on it too, and their population began to rise as well, partly also because there were more berries growing on the regenerating shrubs. And the bears reinforced the impact of the wolves by killing some of the calves of the deer. But here's where it gets really interesting. The wolves changed the behavior of the rivers. They began to meander less. There was less erosion. The channels narrowed, more pools formed, more riffle sections, all of which were great for wildlife habitats. The rivers changed in response to the wolves. And the reason was that the regenerating forests stabilized the banks so that they collapsed less often, so that the rivers became more fixed in their course. Similarly, by driving the deer out of some places and the vegetation recovering on the valley sides, there was less soil erosion because the vegetation stabilized that as well. So the wolves, small in number, transformed not just the ecosystem of the Yellowstone National Park, this huge area of land, but also its physical geography.
All right, we'll go ahead and stop there. Okay, so there was so much information and so much evidence that we could write down. Remember, what we're trying to listen for is examples of how the wolves have a huge impact on their environment, why we would call them a keystone species. Our claim is that they're a keystone species. What's our evidence? The impact that they have on their environment. So there are so many things that you could write down. And if you want to write down different things than I'm writing down, more power to you. I'm not going to write down everything. The first thing that they did, they lead to fewer elk, and they lead to the elk moving around more. So the elk were just complacent, sitting in the same spot, eating all of the plants and trees in the same area because they didn't have any wolves to worry about until the wolves came back. And then the elk began to their numbers began to go down, and they had to move and hide and escape and go to other areas of the park. So they weren't eating the entire all the plants in that one area. So then, because there were fewer elk, more trees because they weren't being eaten as much. Okay, so we have more trees. We have fewer coyotes. There's so many things we could write here. I'm just writing some of them. Fewer coyotes because coyotes. Why are there fewer coyotes? Because the wolves killed them because they are competitors. Okay, so fewer coyotes because the wolves killed them. Well, when you have fewer coyotes, the food that the coyotes eat increases. So we see more rabbits, more hawks. The hawks eat the rabbits, more beavers, more mink. There were so many other animals that they mentioned, like I can't keep up with all of the impacts. And then the last one was the crazy one. It wasn't even an impact on animals directly. The rivers are more stable now that there are wolves in Yellowstone because the increase in trees stabilizes. Oh, I wrote the rivers are more stable. The rivers are more stable because it stabilizes because an increase in the trees stabilizes the banks of the rivers. Stabilizes. There we go. Okay, moving on. Let's scroll down to the next one. So we've got lots and lots of evidence that wolves are this keystone species in Yellowstone. So now we want to know, based on what we've been learning, do the wildebeest qualify as keystone species in the Serengeti? So we have another video that we're going to watch. It's about 3 minutes long, something like that. I don't remember exactly. And I'll play it big. Make it full screen if that made sense.
For the next 3 years, Tony keeps a close watch on the wildebeest, looking for signs they're overgrazing the grasslands. But after 2 more counts, numbers remain steady at 1.4 million.
At that point, we knew that the system had leveled out of its own accord, and there was no damage to the environment.
The wildebeest find their natural balance. But what happens next amazes even Tony. He and his colleagues witness an incredible transformation.
To our surprise, we found that all of a sudden things started to reconnect with each other. Because the wildebeest were eating up the grass, there was less fuel and therefore less burning. That allows young trees to grow. Wildebeest, of course, do not eat trees, and that allowed the tree populations to increase. Tree populations that probably hadn't occurred since the 1800s. Those trees provided more food for elephants, for giraffes, and for many, many bird species. And then there are many more predators because there's more food for those too. The wildebeest in their huge numbers were determining everything else inside the park. I realized that wildebeest was a keystone. We had always assumed that keystones had to be a predator, but we realized that a keystone could actually be herbivores.
And if removing keystones causes collapse, returning them leads to rebirth.
we were seeing a recovery, an upgrading of the whole ecosystem for the first time.
All right. So, gosh, I think that's just such a beautiful video for us to watch. Okay. So, again, there were a lot of things that were said as evidence to support that wildebeest this time are the keystone species in the Serengeti. So, there's different things that you could type. I'm going to type some of them. Some came from the video, some's from research we've already done. So, let's say more wildebeest equals more food for predators like lions, but there were other predators. Like he mentioned that there's more types of predators now. So that's one impact that the wildebeest are having. There's more food for the lions. Less lion predation. Less lion predation means more surviving giraffe calves. And so that population is on the increase. Awesome. Obviously, we learned about that there's grass, so more, the grasses that they eat, more wildebeest. Is it torturing you to watch me type? More wildebeest equals less grass. And what does that do to the fires? Equals less intense fires. And then let's take that step. Less intense fires equals more trees. And then what's the impact of more trees? More, what happened there? More trees equals more food for giraffes, elephants. This came right from the video. Elephants, birds, ... and other animals that need those trees. So remember that the wildebeest population was low after rinderpest. Rinderpest killed many of them, but we've seen this wildebeest population skyrocket. And the question is it bad? Should we have so many wildebeest? And the answer is no. This is what the Serengeti is supposed to have. We want the wildebeest. It's not bad because they're doing so much good for so many other animals. So what evidence, if any, contradicts or does not support that claim? None that we've seen. We haven't seen anything that makes them like they're not that important of an animal. Just imagine what would happen to the Serengeti if the wildebeest weren't there. All right, we're really close to the end. Some conservationists, people who want to protect the environment, argue that the wildebeest should be protected on the Serengeti. They're obviously not an endangered species. Why would we protect them? Even though the size of the wildebeest population is large, in order to protect the ecosystem in the future, some local governments have sought to get rid of wildebeests in their countries because the animals threaten livestock, like cows, that people depend on to eat. So would protecting the wildebeest help to protect the stability of the Serengeti ecosystem? Why or why not? So the wildebeest, we think we've got great evidence that they're a keystone species. So as a keystone species, their impact is enormous, right? No other organism can control the grasses and fires the way the large wildebeest population does. The reduction of fires impacts, get my picture out of the way, impacts many different species of plants and animals, impacts many different populations of plants and animals. So if we don't protect the wildebeest, if the wildebeest are allowed to have something bad happen to them, it's going to have a ripple effect through the entire Serengeti. We're going to see all kinds of animals having trouble. So then it says, should governments give special protections to wildebeest? Why or why not? Well, protecting the wildebeest is the same as protecting all of the other organisms in that ecosystem, So protecting the wildebeest means that the ecosystem stays stable and healthy for all of the other animals. However, there's always another side to these, right? The growing human population in the area, may mean that some of the land is needed for agriculture. And agriculture could be farming or it could be cattle, ranching, so agriculture. All right, and then finally, what are some negative effects of on other organisms in the ecosystems of your proposal? So if we propose to protect the wildebeest, who's going to be impacted negatively? Well, but the only thing that I can think that would be impacted negatively would be cattle and farms. So more wildebeest equals less available land for cattle. There's going to be less grass for cattle and farms. And that's a problem for that growing population. So, which are we weighing? Which is more important, the stability of that entire ecosystem or the human beings that live in that area? And that's not an easy answer. Okay, nerds, that is it. You are all done. Go ahead and turn it in. Let me know if you have any questions. Peace.